Okay, let's take a look at a subcooling example. Here we have a split system residential, and it's an R22 with a TXV, and the manufacturer requires 9 degrees of subcooling. So you remember that subcooling occurs when a refrigerant is cooled below its boiling point, and the boiling point is found by using the pressure temperature chart. So you hook up your manifold gauges and your temperature clamp on the liquid line, the high side, at the condenser. After you let the system run for about 15 minutes, you get your pressure temperature chart so you can determine the boiling points. And here's how the setup might look, with your manifold connected, your high side to the high side, and your temperature clamp on the liquid line, which is the small copper line. And here's what you observe. You get a high side pressure reading of 212 psi-G, and your liquid line temperature is actually 94 degrees Fahrenheit. So it's time to pull out the R22 PT chart and find out your readings again. So recall that your pressure was 212 psi-G and that your temperature was 94. But if you look closely at the chart, you'll notice that 212 degrees is not on the chart. So we're going to look closely and see if we can find an approximation. So looking at the chart, we see that the 210 value is closest to 212, so we're going to use that pressure. And the boiling point for 210 is 105 degrees. Since our liquid line temperature is 94, we know that we do have some subcooling. But how much? Well, we recall the formula for subcooling is the saturated condenser temperature minus the liquid line temperature. We have 105 degrees minus 94, giving us 11 degrees of subcooling. So we are slightly higher than our required 9 degrees, but close enough for manufacturer specs.